All right, so we're going to be moving on to Unit 12, which talks about the behavior of gases and, in particular, the gas laws. Up to this point, when we've been dealing with gases, we've had a constant pressure and a constant temperature, or standard temperature and pressure, or STP. Now things are going to change where those aren't always constant. So I'm going to give you 3 different gas laws. And with each of these 3 gas laws, we're going to hold either pressure, volume, or temperature constant for each of those. And then at the end, we're going to make things really easy for us, and we're going to combine all those 3 gas laws into what we call the combined gas law, and then we can just use that one. But to gain a really good understanding, I like to cover each of those gas laws, and then before we combine them, and then we'll combine them and use that one. So today, the first one we're going to cover is Boyle's law, which we're going to hold temperature constant. We're going to assume the temperature is constant. So for Boyle's law, for a given mass of a gas at a constant temp, and again, we're going to hold the temperature constant here for Boyle's law. The volume of the gas is going to vary inversely with the pressure. Okay, so there's an inverse relationship between our pressure and our volume. So it varies inversely with the pressure. So an inverse relationship meaning when one goes up, the other one goes down, and vice versa. In an inverse relationship, the product of our 2 numbers is going to be our constant. So product of 2 numbers is the constant. Okay, and that constant we're going to label with K, and it doesn't have a unit. Most constants don't. So our K, which is our constant, is going to be equal to P times V, pressure times volume. And again, we're assuming in this Boyle's law that temperature is held constant, but our pressure and our volume can vary. Okay, but no matter how, if the temperature is constant, that pressure and volume vary. No matter what they vary to, we're always going to get the same constant dealing with that same gas when the pressure and volume changes. So the law, Boyle's law states P1 times V1 equals P2 times V2. The pressure of gas number 1 and times the volume of gas, the first gas, is going to be equal to the pressure of the second gas times the volume of the second gas. Okay. All right. So let's go ahead and do a sample. So this is Boyle's law here. P1 V1 equals P2 V2. We're going to take that and go ahead and do a sample problem. So let's just stay with this. Sample problem out of your textbook is going to be on page 335. Let's do sample problem 12.1. And again, this is on page 335. So it states a high altitude balloon contains 30 liters of helium gas at 103 kilopascals. So the pressure is 103 kilopascals. What is the volume of the balloon when the balloon rises to an altitude where the pressure is only 25.0 kPa? So here's the values or variables that were given in the problem, and it's asking what is the volume when the balloon rises to an altitude at this pressure. Okay, so we start with P1 V1 equals P2 V2, and our pressure of 1 is going to be 103 kilopascals. Okay. Our volume of 1 is going to be 30. It's 30 liters. Equals our pressure of 2 is going to be 25 kPa. That was the pressure it was at that high altitude, 25.0. And then our V2 is our unknown. So again, it doesn't state anything about temperature in this problem, which means we're going to assume that temperature, that given temperature, is constant. So we know we need to use P1 V1 equals P2 V2. Go ahead to solve for V2, isolate V2, divide by 25.0, divide by 25.0. 103 times 30 divided by 25.0, and again we're looking at volume, which is going to be in liters. You're going to get an answer to 3 sig figs of 124 liters. So you'd have 124 liters of gas at this pressure. So if you look, our pressure went way down. It went down from 103, and as it got high in altitude, the pressure went way down. We've talked about that, went down to 25. But if you look, it's our relationship with our volume is going to be an inverse relationship. It went down, the pressure went down, but what happened to our volume? It went way up, right? It was at 30 liters. It expanded and went all the way to 124 liters. So hopefully that makes sense to you. Boyle's law, temperature's constant. P1 V1 equals P2 V2. You may have to solve for any of these variables. Just make sure and match up the correct pressure with the correct volume. Make sure you match those up. So